This last section on inequalities is a difficult one to understand. It's inequalities with absolute value. Now, we already did equalities with absolute value, and that was pretty straightforward. So let's look at the question here that's posed. It says, what if you have an absolute inequality? Well, there are two types of absolute inequalities. Type 1 is an inequality that has a less than or equal to. Type 2 is a greater than or equal to. So let's look at type 1. I don't think you're going to have trouble with type 1 because it's very similar to the equality that we already did. So it says solve the inequality. We have the absolute value of x is less than 4. So here is 4, here is 0, here is -4. Those are some key regions here. So if the absolute value of x is less than 4, then what that really means is that x is in between 4 and -4. Think about it. Let's think about it. Let's try some numbers. I'm going to put a -5 here. I'm going to put a -3 here. And then over here, I'm going to put a +3. So let's just take a look. Over here, we'll put a 5. So what we're going to do is we're going to look at the regions on either side of -4 and +4. So let's look at this region first. So we're going to try -5, and we're going to see if this makes a true statement. Is the absolute value of -5 less than 4? Where the absolute value of -5 is 5. Is 5 less than 4? No, that is a false statement. So this region is false. Now let's look in between -4 and 4. We can just pick any number we want. I can try -3, 3, 0. I'm going to try -3. So let's try -3. Then I would have the absolute value of -3 is less than 4, but the absolute value of -3 is 3, and 3 is less than 4. That is a true statement. If it works in the region for one test point, it works for all of them. So I know that all of this region is true. Now let's try this region. So let's try +5. So let's try +5. Is the absolute value of +5 less than 4? Is 5 less than 4? That is not true. So this is also false. So the only part that gave us a true statement was the region in between -4 and +4. And that's why we say when you have an inequality is less than a number, it just means that that x, or whatever is in the absolute value, is between the negative of this number and the positive. So I tested all of those regions, and I got a false, a true, and a false. So type 1, conclusion. If you are given an absolute inequality that contains either less than or greater than, isolate the absolute value. That's super important. It was already done in this one. And then put the absolute value expression between the negative and positive of whatever is on the right side of the inequality. So let's try one. So rather than trying to test this out on the number line, the absolute value piece is already isolated. So what I'm going to do is take what is in the absolute values, which I'm going to write means, which is 2x plus 4. And then I'm going to put it between, with the same sign, positive of the 3 and negative of that, whatever's on the right. So, of course, the negative one goes on the left and the positive one goes on the right. The absolute value goes in the middle. Now, all I have to do is solve this, and I will get on my number line something whose region is true, just like I tested up here. So I have -7 is less than or equal to 2x is less than or equal to -1. I divide everything by 2, and what I end up with is x, and it's in between a -1 on this side and a negative 7/2 on this side. So negative 1/2, I think I said negative 1, negative 1/2 and negative 7/2. This is my inequality form of the answer. I could put it on a number line. We're not going to do that. We're going to go straight to the interval notation. So the interval notation would be it includes negative 7/2 and it goes up to negative 1/2 inclusive. So here is the inequality, here is the interval, and I would want both of those. Let's try another one. The absolute value is already isolated, so we put it in the middle. Now I'm going to put less than 5, and then I'm going to put negative 5 on this side with the same symbol. Now I solve. I'm going to subtract a 1. I get negative 6, negative 4x, less than 4. I divide by negative 4, and we know what dividing by a negative does. Negative divided by negative is a positive, and that simplifies to 3/2. But because I divided by negative, I flip the sign. And now it's in the wrong order. So I have to turn the whole thing back around. So negative 1, flip your sign, put your x there, 3/2. So here it is as an inequality. You could put it on a number line. I'm assuming you can do that. But as an interval, it's going to be negative 1. Look, it's not included, and it goes up to 3/2, and 3/2 is not included. So there it is as an interval. So just to sort of recap the type 1. Type 1 is when you have a less than or equal to. You isolate the absolute value. That was already done for you on the 2 examples. You put what was in the absolute value goes in the middle, and then whatever is here, the positive goes here of it, the negative goes here, and you keep your symbol as less than. All right, that is quite a bit easier than when we have a type 2. Type 2 is when you have a greater than or equal to. So let's do the same thing that we did up here where we tested those regions. I have absolute x greater than 3. So I'm going to put a 3. I'm going to put a negative 3. I'm actually going to do this in colors. In between, we'll have it be blue. On this side, I'll have it be red. That's another region I'm going to test. And then on this side, I'll do this in green, and that is another region that I have to test, something from that region. So first off, let's test something that's in between negative 3 and 3, like 0. So let's test that. So we would say, is the absolute value of 0 greater than 3? Is 0 greater than 3? Well, no, it's not. So that is false when I tested 0. That region, that whole blue region here, is false. Let's test the green region. Now, I don't want to test negative 3. I want to test something on this side of it because it goes this direction. So let's test negative 4. So is the absolute value of negative 4 greater than 3? Absolute value of negative 4 is positive 4. Is 4 greater than 3? Yes, it is. So when I tested negative 4, it was true. Now let's test something in this red region. Let's test just 4, make it simple. So now I've got absolute value of 4 is greater than 3. Is 4 greater than 3? That is also true. So everything in the red region is true. So how are we going to show that on our number line? I'm going to have to redo that number line. So on the number line, what I want to show is this. Here's negative 3, here's positive 3. None of this worked, but everything on this side of negative 3 worked. So I'm going to put that, and it goes this direction. And everything on this side of positive 3 works. So I'm going to do that and go that direction. That means they're not included, but nothing in the middle worked. So I leave it that way. Let's see what kind of conclusion we can draw then about type 2. So at the top of the next page, sorry, probably making you seasick. At the top of the next page, we have our type 2 conclusion. And this is where, like I said, it's a little bit harder. If you're given an absolute value that contains a greater than or equal to, isolate the absolute value, and then you set the absolute value expression as greater than the right-hand side or less than the negative of the right-hand side. So what does that mean again? Well, let's look. So here's what this means. It means the absolute value has already been isolated. It means that 2x minus 5 is less than negative 3, or 2x minus 5 is greater than positive 3. So now I have to solve this. I add a 5 to both sides. I get 2x is less than 2. I divide by 2. I get x is less than 1. Or here I add a 5 and I get 2x is greater than 8. I divide by 2 and I get x is greater than 4. So on a number line, this is my 0, I have 1 and 4 as my key numbers. And what is the region that works? Everything that's greater than 4 or less than 1. It goes that direction. So let's try a couple. I'm going to give you a couple of on your owns. So let's try this first one. Is the absolute value of 3t minus 2 is less than 4. Okay, that's a type 1. So that's number 1, and I know because it's in a less than. Here's the second one. The absolute value of 1 minus 2x minus 4 is less than negative 1. You're going to have to do something with this because this isn't isolated. That is also a type 1. And here's the third one. Absolute value of 3x plus 4 is greater than or equal to 2. This is a type 2. So 2 less thans and 1 greater than. All right, before we do these 3 on your owns that I gave you to try while you paused, let's go back to this one, because one thing that we did not show is how you write this in interval notation, and this is a little bit of a hard one. We know that this is true, or this, x can be less than 1 or greater than 4. So to show that in interval notation, think about what is the furthest this goes on the left. It goes down to negative infinity. So what we're going to have to do is say negative infinity up to 1, not including 1, and then this symbol means in union with or along with, and then we start at 4 and we go up to positive infinity. So this is the way that you write the interval notation for this kind of problem. So let's work these 3. Remember, the first one is a type 1. My absolute value is isolated, so I'm going to take the absolute value bars away, take what's in between. I'm going to put it between what's here and the negative of that. And then I'm going to solve by adding the compound, or by adding a 2, solving the compound inequality. And I have 3t, and then I have is less than or equal to 6, and then on this side I have negative 2 is less than or equal to 3t. So now we divide by 3. We get negative 2/3 is less than or equal to t is less than or equal to 2. I didn't divide by negative. So here it is as an inequality. On a number line, my key numbers would be negative 2/3. There is a bracket there, and it goes up to, if this was 0, it goes up to 2. There is a bracket here, and remember, type 1, it's all the stuff that's in between. As an interval, I can go right underneath that. Let me bring this up so you've got room to see. Right underneath that, and I'm going to write bracket negative 2/3 up to 2 bracket. So there it is, all 3 ways. We don't need to write it as a set. All right, let's look at this one. This is another one that is a type 1 because of the less than, but the absolute value is not isolated. So I'm going to add a 4 to both sides. I get absolute 1 minus 2x is less than 3. Now I take the absolute value away. I write the right-hand side, and then I do the left-hand side, and I solve. So we subtract a 1. Negative 4 is less than negative 2x is less than 2. We divide by a negative 2, which is going to cause the symbols to flip. And now I got to turn the whole thing around because it came out backwards. So there it is as an inequality. On the number line, I have negative 1 and 2. I know it's the stuff in between because that's a type 1, so I'm just going to put parentheses, and it's everything in between, so then I can go underneath and do my interval. All right, let's look at finally the type 2, and I know it's a type 2 because it has a greater than sign. It's already isolated, so I'm going to write either 3x plus 4 is greater or is less than, or equal to negative 2. So that's the first half. Or 3x plus 4 is greater than or equal to positive 2. So when we bring over the negative 2, we turn that sign around. Now I solve. 3x is less than or equal to negative 6. I divide by 3, and I get this. Or here I subtract a 4, and I get 3x is greater than or equal to negative 2. I divide by 3, and I get, or x is greater than or equal to negative 2/3. So on my graph, my key numbers are negative 2 and negative 2/3. My 0 would be here. And I know that it's this region or this region. Are they included? Yes. Nothing in between. So it's the outside regions. So how do I write that? It would be negative infinity to 2, close the bracket, in union with negative 2/3 to positive infinity. So here it is as an interval. And that's the hardest part about type 2, is writing it as the interval.